Okay, in this demo we're going to look at doing a regression of stature on metacarpal length, as we talked about in lectures, and we're going to look at interpreting the test for significance of a linear relationship, look at how we find r squared and what it means, and look at some residuals from this particular analysis. Alright, so we've already loaded the data. The first thing we need to do is to fit the regression model. Okay, so we go to Fit Models, Linear Regression. Okay, and we choose here on the left the response variable. Now for us the response variable is stature, that's the variable we want to predict. And then on the right we get to choose the explanatory variable or the x variable, and for us that's metacarpal length. That's all we do here, and we click OK. Okay, and then down the bottom we get all of the output. We can see that the estimated intercept is 94.428, the estimated slope is 1.700. And then for the slope we have the standard error of that slope, so that would be s over the square root of the sum of squares for x, and that turns out to be 0.388. Okay, and the t-value, which is simply the ratio of that estimate to the standard error, and that's 4.380 in this case. And that gives a p-value of 0.00323. Okay, that p-value is significant at pretty much any level you'd be interested in, 1%, 5% or 10%. Therefore, there is a significant linear relationship between these two variables. What else is there in here? Well, we can see the estimate of standard error there, 4.255 on 7 degrees of freedom. Okay, the 4.255, that's S in lectures, as we called it, and 7 degrees of freedom, that's n minus 2. So there are 9 observations in the data set, so n minus 2 is 7. The other point of interest is the number labelled multiple r squared. This is what we called r squared in lectures. The adjusted r squared is something slightly different. We'll just ignore that for the time being. The multiple r squared is 73.27, so that means that the regression is explaining about 73.27% of the variation in stature. The last line there is an f statistic, and in this case for simple linear regression the f statistic 19.19 is simply the square of the t-value for the slope. So if you calculate 4.380 squared you'll get 19.19. And the p-value is the same, 0.00323. There's one extra decimal place there, that's all. Okay, the other thing we might want to do is look at the residuals for this. So the two types of plots we're interested in are called the residuals versus fitted values. Now we do this through the Models tab, not the Graphs tab. In the Models tab we can see down the bottom a bunch of things labelled graphs. The first thing we look at is basic diagnostic plots. That's the top level there. If you plot that one, you'll get a bunch of plots. There are actually 4 plots that are produced by default. We're primarily interested in the top left panel here, which is residuals versus fitted values. We talked about that in lectures. Any evidence of fanning out there indicates non-constant variance. There's not very much data here, so it's difficult to see exactly whether there's any fanning out or anything. There's only 9 data points. You can see there at the top right something called the standardized residuals versus the theoretical quantiles in a normal QQ plot. That's a normal probability plot. There's a couple of points a bit above the line, but we're not too worried about that. We can actually get that plot again if we go back to Models, Graphs, see the residual quantile comparison plot, click OK. Okay, and that produces a very similar plot, but with an envelope now that is simulated from, so the envelope is simulated from the actual model. It's a more complex version of that plot. It's quite difficult to see the data points there. We might go back. I think we can change that here. Okay, so we see that there's not much evidence of a difference from normality. There's a couple of points seem to be outside the envelope, but they're still pretty close to the regression line, to the line there. Okay. That's the end of this demonstration.